The ultimate roadmap to self-study AI. Imagine a world where you can harness the power of artificial intelligence, where you can build intelligent systems, predict future trends, or even teach machines to think like humans. Now imagine doing all of this without spending thousands of dollars on expensive courses or degrees. Sound impossible? It's not. Today, I'm sharing the ultimate roadmap to self-study AI, a step-by-step guide that mirrors Stanford's renowned AI curriculum, but adapted for anyone, anywhere, for free. Whether you're a tech enthusiast, a student, or someone simply curious about AI, this roadmap is designed to take you from a beginner to someone capable of tackling real-world AI challenges. Stay with me, because by the end of this guide, you'll have everything you need to kickstart your AI journey. When I first began my journey into AI, I was overwhelmed. There were endless online tutorials, books, and forums, all claiming to have the best approach. The problem? It was hard to tell which resources were genuinely useful and which were a waste of time. It felt like trying to drink from a fire hose. Too much information, not enough clarity. That's why I created this roadmap. It's not just a collection of random tips, it's a structured, step-by-step plan inspired by Stanford's graduate AI program. This isn't just about learning. It's about learning smartly, efficiently, and cost-effectively. Before we dive into the roadmap, let's talk about expectations. AI is not something you can master overnight. Even Stanford students spend 1-2 years studying part-time, and as a self-learner, your timeline will depend on your prior knowledge, schedule, and commitment. This is a marathon, not a sprint. Think of it like building muscle at the gym. It takes consistent effort, patience, and dedication. But the reward? A skill set that's in demand across every industry imaginable, from tech and healthcare to finance and entertainment. The key is not speed, but understanding, really grasping the concepts and their applications. Why math is the cornerstone of AI. AI might seem like magic, but it's powered by the precision and logic of mathematics. Every intelligent system, from a recommendation engine suggesting your next binge watch to a self-driving car navigating a complex intersection, operates on a mathematical foundation. Mastering math enables you to demystify AI. It's how you go from passively using AI to actively creating it. Why is math so critical? Because it explains the why and how behind the algorithms. It allows you to understand what happens under the hood when a machine makes predictions, recognizes images, or learns from data. Without math, AI becomes a black box. With math, you hold the key to innovation. Here's what you need to build your foundation. Calculus is the backbone of many AI techniques, particularly in machine learning. Its concepts, derivatives, integrals, limits, and optimization are used to train and fine-tune models. One of the most crucial applications is gradient descent, an algorithm that helps machine learning models minimize errors by iteratively adjusting weights. Without calculus, this process simply wouldn't exist. Imagine teaching an AI to recognize handwritten digits. The model needs to improve its predictions by tweaking its internal parameters, and gradient descent ensures those tweaks are efficient and effective. That's calculus in action. Where should you start? For free resources, platforms like Khan Academy and MIT OpenCourseWare provide excellent tutorials. If you prefer books, consider Calculus by New Horizons, 6th edition or later. Dedicate time to understanding these concepts deeply. They're your entry point into the world of machine learning. Linear algebra is the language of data, and in AI, data is everything. Vectors, matrices, and transformations are central to almost every AI model. Neural networks, for example, process data in matrix form, and linear algebra helps these systems understand relationships within the data. Let's say you're building a facial recognition system. Behind the scenes, every image is represented as a matrix of pixel values. Linear algebra operations like matrix multiplication allow the system to extract and compare patterns, enabling it to recognize faces with remarkable accuracy. To get started, explore resources like Linear Algebra, done right by Sheldon Axler, or Gilbert Strang's MIT course, available on YouTube. Break the subject into digestible sections and don't rush. The more comfortable you are with linear algebra, the easier you'll find more advanced AI topics. If linear algebra is the language of AI, probability and statistics are its intuition. These fields teach you how to make sense of randomness, uncertainty, and patterns. They're the tools you'll use to design AI models that can make informed predictions, like forecasting stock prices or detecting fraudulent transactions. Consider a spam detection system. The AI uses probabilities to classify emails as spam or not spam based on patterns it identifies in the data. For instance, the appearance of certain keywords might increase the probability of an email being spam. Free resources like MIT's Introduction to Probability and Statistics offer a comprehensive overview of key concepts, including distributions, conditional probability, and regression. These are the building blocks of advanced AI techniques, so take your time mastering them. Theory alone won't make you an AI expert. Practical application is where the real learning happens. As you study linear algebra, try building a basic image recognition program. Use your knowledge of probability to create a dice roll simulator that predicts outcomes. Small projects like these reinforce what you've learned and show you how math directly powers AI. They also keep your learning journey exciting and interactive. By the way, if you're finding this breakdown helpful, imagine how much more you'll gain by subscribing to this channel. Every week, I'll bring you new guides, tips, and insights to supercharge your AI journey. Don't miss out. Hit that subscribe button and let's build your future in AI together. The importance of math becomes even clearer when you think about AI applications in the real world. Take natural language processing, NLP, for example. When an AI model like ChatGPT processes text, it's calculating probabilities to predict the most relevant response. Every suggestion, every phrase, and every nuance is powered by the math you're learning. Or consider autonomous vehicles. These cars rely on linear algebra to process visual data and calculus to optimize routes and avoid collisions. Probability helps them anticipate the actions of other drivers. Math isn't just a subject you need to pass, it's the foundation for building systems that solve real-world problems. The more deeply you understand it, the more capable you'll be of designing innovative solutions. Before we move on to programming, let me leave you with this. Approach math not as a hurdle, but as an opportunity. Every concept you master is a tool in your arsenal, preparing you to tackle bigger challenges. AI may seem complex, but it's built on simple ideas combined in powerful ways. Take your time, enjoy the process, and remember, every expert in AI once started where you are now. You're laying the groundwork for something incredible. Ready to move on? Let's dive into programming, where you'll turn these concepts into real-world solutions. Now that you've laid the mathematical foundation, it's time to bring AI to life through programming. Think of programming as the bridge between theoretical concepts and real-world applications. It's how you take all those mathematical formulas and turn them into something tangible, an algorithm, a chatbot, or even a self-driving car. But here's the thing. Programming for AI isn't about memorizing syntax or writing fancy code. It's about problem solving and thinking like a machine. You don't need to be a coding prodigy to succeed, you just need the right mindset and a willingness to learn. Here are the key areas to focus on as you begin. Most AI tools run on Linux-based systems. Learning the Linux command line might not sound glamorous, but it's a game changer. It allows you to set up environments, manage datasets, and automate repetitive tasks, all critical for AI projects. For example, imagine you're working with a massive dataset for a machine learning model. With Linux, you can quickly navigate directories, manipulate files, and even run scripts that process thousands of data points in seconds. Start with beginner-friendly guides like Linux Academy or Ubuntu's Getting Started Guide. Spend a week or two familiarizing yourself with basic commands like navigating directories, editing files, and managing permissions. Once you're comfortable, you'll wonder how you ever managed without it. Object-oriented programming, OOP, is all about organizing your code in a way that's reusable, scalable, and easy to understand. For AI, this is especially important. When you're building complex models or working with large data sets, a structured approach can save you hours, if not days, of debugging. Key concepts like classes, inheritance, and methods are the building blocks of OOP. They allow you to break down large problems into smaller, manageable pieces. For instance, in a machine learning project, you might create classes for data, pre-processing, model training, and evaluation, making your code cleaner and easier to maintain. Free resources like Codecademy or FreeCodeCamp offer excellent OOP tutorials. Dedicate some time here. It's a skill that will pay off throughout your AI journey. AI thrives on efficiency, and that's where data structures and algorithms come in. They're the tools that allow you to optimize your AI systems for speed and scalability. Let's say you're designing a recommendation system for an e-commerce platform. Efficient algorithms enable your AI to process thousands of products and user preferences in real time, delivering personalized suggestions in milliseconds. Focus on learning. Lists and arrays for handling collections of data. Stacks and queues for managing data flows. Sorting and searching algorithms for organizing and retrieving information quickly. Platforms like LeetCode and HackerRank are fantastic for practicing these concepts through real-world coding challenges. If there's one programming language you need for AI, it's Python. Known for its simplicity and versatility, Python is the go-to language for AI development. Start by learning the basics. Variables and data types. Control structures like loops and conditionals. Functions for modular programming. Once you've mastered the fundamentals, dive into Python's AI-specific libraries. NumPy for numerical computing. Pandas for data manipulation and analysis. TensorFlow and PyTorch for building and training machine learning models. Free resources like Google's Python class and the book Automate the Boring Stuff with Python are great places to start. Dedicate at least 4 to 6 weeks to Python basics, followed by another 4 to 8 weeks exploring these libraries. Think about the last time you interacted with a customer service chatbot. Behind that smooth conversation was a Python-powered AI model, trained to understand your queries and respond intelligently. The chatbot's natural language processing capabilities were built using libraries like TensorFlow and PyTorch. Its ability to handle multiple users simultaneously? That's where data structures and algorithms came into play. As you master programming, you'll gain the skills to create your own intelligent systems, whether it's a chatbot, a predictive model, or a groundbreaking application no one has thought of yet. Programming isn't just about writing code, it's about bringing ideas to life. Every time you debug an error or optimize a function, you're solving real-world problems and contributing to the future of technology. Remember, this is a skill you'll refine over time. Start small, stay consistent, and don't be afraid to make mistakes. They're a natural part of the learning process. And if you're enjoying this guide, make sure you're subscribed to the channel. We're just getting started, and there's so much more to explore in AI and beyond. Let's move on to the next phase, diving into AI fundamentals. Ready? Let's go! You've just completed 2 of the most important steps on your journey into AI. With a solid foundation in math and programming, you've equipped yourself with the essential tools to dive into the exciting world of artificial intelligence. Think about it. You now understand how the magic happens, from building models to writing the code that powers them. But this is just the beginning. In the next part, we'll dive even deeper, exploring the heart of AI fundamentals and unveiling the skills that will set you apart. From understanding how machines learn to building projects that solve real-world problems, the most thrilling part of your journey is yet to come. Make sure you're subscribed so you don't miss it, and if you're ready to take your learning to the next level, click over to part 2 right now. Your AI adventure is just heating up.